Alright. So now we're in section 2.2, where this talks about being able to identify and find a slope in a line. We've been working with slope for some time now. A lot of this is a review from beginning algebra. And starters, slope is the ratio of the vertical change, which means it's the change in y values over the horizontal change, which is the change in x values of a line. Slope is represented as the letter m, and the equation for it is right here, where we have y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, these points are values, or sets of ordered pair in which determine what the slope of a line is. Again, so this is the difference in x values, difference in y values, vertical change to horizontal change. And again, we have rise over run. Alright, so if I were to look at slope on the graph on my left, so if I were to say, it's kind of a interesting graph, so say if I was going to take this point here, excuse me, and then look at this point here, I'm going to rise, I'm going to go up 1, 2, 3, so I rose up 3 over 1, 2, 3, 4, 5. So my slope for this particular line would be 3 over 5. So I'd rise up 3, and then I would go to the right 5. And this is a better representation of how we use our y2 minus y1 and x2 minus x1. So if I am looking at types of slopes, so let's see if I can delete this. Okay, so types of slopes, if we're looking for one that has a positive slope, it kind of puts it into a direction looking like this. And a negative slope means that either our rise or our run is negative. It's either one or the other. Horizontal slope means it has a slope of 0. And then a vertical slope, our slope is undefined, which means like whatever value it is on top, it's divided by 0. Okay? Other values that, or other types of lines that help determine, are determined by slope, are parallel lines, which are right here, and then perpendicular lines, which are right here. And one of the things that we have to keep in mind for when we're dealing with parallel lines, for lines to be parallel, they must have the same slope. So if we're going to use M to represent our slope, this line has to be a slope of M, and this line has to be a slope of M. Okay? When I'm looking at perpendicular lines, this means that each line is 90 degrees from one another. So let's just say that this is line number 1 and this is line number 2. Line number 1, for example, let's just say it has a slope equaling 2, just for example. For line number 2 to be perpendicular, the slope must be what is called the negative reciprocal of the other line. So what I need to do is I need to flip the fraction. So let's just pretend that this is like 2 over 1. So if I were to flip the fraction, it would be 1/2, and then I gotta change the sign. So if my first value is positive, this one's going to be negative. So for a more general term, to have M perpendicular, it must be what is called the negative reciprocal of m. Here, I want to find the slope with the given points, tell whether it is positive, negative, horizontal, or vertical, then state the slope of the line parallel to it and perpendicular to it. So for A, B, C, and D, we are given coordinates. This can be considered our x1, this is our y1, this is our x2, this is our y2. So all we're going to do is use our slope equation and plug it in to get our slope. So my y2 is 15 minus 7 divided by negative 16 minus a negative 8. 15 minus 7 is 8. This becomes plus plus. Got negative 8, which equals a negative 1. For A, this has a negative slope. For this slope of a line parallel, that slope would have to be a negative 1. And for it to be perpendicular, it would have to equal a positive 1, because if you flip the fraction, change the sign of 1 over 1, it still is 1. So now let's look at B. So I'm going to say x1, y1, x2, y2. So I got negative 10 minus 7 divided by 4 minus 4 equals negative 17 divided by 0. So what we talked about in the previous slide, if our value in the denominator is 0, that means that it's undefined. So if it's undefined, we can make the conclusion that it is a vertical line. So nice little note, if we have the same values and the same symbol, if they're both a positive 4 in the x coordinate, we can make a conclusion that our value or our line will be vertical. And if I'm looking for a parallel line to this, so it's any other value that is also a vertical, but with different x coordinates. Or, yeah. So what I want to do now is determine what it would be for a parallel. So if I did parallel, it would be perpendicular, I'm sorry. The negative reciprocal would be positive 0 over 17, which would equal 0. So a horizontal line is perpendicular to a vertical line, which makes sense. So if I look at C, again, I'm going to go negative 1 minus 7 divided by negative 2 minus 6 equals, would be what, negative 8 over negative 8. And that would equal 1. This is a positive slope. And if I had a slope that's parallel, slope would be 1. If I had a perpendicular, it would equal a negative 1. Flip the fraction, change the sign. So if I look at D, I'm going to go negative 2 minus a negative 2 divided by negative 5 minus 8. Plus plus, this gives me 0 divided by negative 13, which equals 0. So if I have a slope of 0, that means that this is a horizontal line. Any horizontal line would make it parallel to this particular line, and any vertical line would be perpendicular to this horizontal line. Okay. Last thing is um, I want to classify the pair of lines as parallel, perpendicular, and neither. So again, we're just going to use that slope formula to determine it. If both values have the same slope, we can say they're parallel. If they have the negative reciprocals of each other, we can say they're perpendicular. If they have neither of those things, then it's neither. So let's get started. So if I have 14 minus 2 divided by negative 6 minus a negative 4 plus plus gives me 12 minus a negative 2, which gives me a negative 6. Now for line 2, if I go 7 minus 4 divided by 12 minus 3 equals 3 over 9, which equals 1/3. Both values are not the same, so they're not parallel. They're not the negative reciprocals of each other, so this would be neither. Looking at B, when I say 8 minus 0 divided by 3 minus a negative 1, so this equals 8 divided by plus plus, that's 4. This gives me a 2. Now here I have 8 minus 6 divided by 4 minus 5, which equals 2 over a negative 1, which is equals a negative 2. They're not the same, so they're not parallel. They are not negative reciprocals of each other because a negative reciprocal of 2 is a negative 1/2, and the negative reciprocal to negative 2 would be a positive 1/2. So they are neither parallel nor perpendicular, so I can say with confidence that they are neither of those things. And that is identifying slope. Hope that helps. Until next time.